Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to see, you can see equivalent capacitance in different cases. So we will see series combination, parallel combination, mixed combination and some other symmetrical combination also. Okay, and here we will calculate equivalent capacitance, charge across the different capacitors, even voltage and whatever things is important, all the things we will see. Okay, so students, let's start the video. So here you can see very well the case one is water, the series combination is there. So here I have taken 6 microfarad, 3 microfarad connected in a series. Okay, and here the battery is there. So let's take here, this is point A, this is point B. Across these 2 points we are going to calculate the equivalent capacitance. So see first one. So when the capacitors are connected in series, what is the formula? 1 by Cs equal to 1 by C1 plus 1 by C2. So when you will simplify this, you can write here Cs equal to C1 C2 by C1 plus C2. So here what will happen, that 6 into 3, that means 18, and 6 plus 3, that means 9. So here you can see very well the equivalent capacitance is coming how much here? 2 microfarad. The first thing is completed, and what we are getting? We are getting the 2 microfarad. Okay. So here if I draw here, the equivalent diagram is there, 2 microfarad here. This is the, how much is there? 100 volt, is it? So this is the equivalent diagram is there. After that, in second case, what we are going to do? We are going to see, let's take charge now across each capacitors. So you know very well the charge in a series combination is always constant. So let's take here charge is Q, here charge how much? Minus Q. So for the charge, what we can write here? Charge is given by Cs into V. Cs how much here? 2. V how much given here? 100. So what is coming here? It will come here 200 microcoulomb. Is it? So here the charge is coming how much? 200 microcoulomb. So remember that here in series combination, whenever we have to calculate the charge across each capacitor, first we will calculate charge across the equivalent. Then same charge will exist here. So here also how much charge is there? Q minus Q, Q minus Q. Value of Q how much here? You know very well, 200 microcoulomb. So 200 minus 200, 200 minus 200. Okay, so in this way we have calculated the equivalent capacitance and we have calculated the charge also. Okay. After that, students, if in case they ask the potential difference, what they ask? Potential difference. Let's take here, what is this? The potential difference is V1, and let's take here, for example, potential difference is V2. Is it? So third one, remember that here, third one, this potential difference V1 across the first capacitor is given by the potential divider method also. I taught in last class. This is a direct formula is there. You can remember that here. Is it? So 1 by C1. Now this is C1. So what we can write here? 1 by 6. Here we can tell 1 by 6 plus 1 by 3 into 100. Okay. You have to just simplify this. You will get the answer in a volt here. Okay. After that, students, if in case they ask here the V2, what they ask? V1 we have got it. So if in case they have asked here the V2. Okay. So remember that here for the V2. So remember that here as V1 plus V2 equal to V. So hence what will happen that here? This V2 is given by V minus V1. Okay. Or we can write here 100 minus V1. So this is the value of a V2 here. Okay, I'm just giving you the idea here. Okay. Similarly, if you don't want to use it, you can use some other method also. You can use like this also. See, V2 equal to, see here the formula, 1 by C2, 1 by C1 plus 1 by C2 into V. So by using this formula also, you can get here the potential, not a problem here. Okay. Remember that here, the next one, what is there? See, we have seen capacitance, charge, potential, is it? And now we will see here the energy here. Okay. So remember that here, if we go for the energy, so see here, in series combination, what is constant? What is constant? The charge is constant. So one number of times they will ask here the energy ratio. So you know very well, U equal to Q square by 2C. Okay. So U is the inversely proportional to C. Okay. So what we can write here, this U1 by U2 is given by what? C2 by C1. Is it? That means if I want to calculate the potential energy ratio, let's take 6 to 3. What I am asking, 6 to 3. So U6 by U3 is given by what? It will given here 3 by 6, and here we can tell here U6 is equal to U3 by 2. That means 6 microfarad capacitor will store half of the energy compared to the 3 microfarad capacitor. And if in case they are asking the value, you can directly use the formula Q square by 2C here. Now you can get it very easily. That's not a problem. Okay. So now students, next one we are going for the which one? Parallel combination. Parallel combination. In parallel combination, what is there? See, 1, 2 and 3 microfarad capacitor connected to 100 watt battery. So first we are going to calculate here the equivalent capacitance. Okay, so see first one, equivalent capacitance formula in parallel, Cp equal to C1 plus C2 plus C3, is it? And directly we can tell, add all of them, 1 plus 2 plus 3, how much it will come here? It will come here the 6 microfarad, na? Very easy. That means if I draw here the equivalent diagram here, how much will come here, see? 6 microfarad, and here how much is given here? This is given here the 100 volt. Okay, so now after that, second one, if I talk about here, let's take charge. So you know very well, as all of them are connected in parallel, that means what will happen? The charge across all of them, like Q1, Q2, Q3. Now let's take here, this is Q1, Q2, Q3, and here anyhow minus Q1, minus Q2, minus Q3. Remember that here, as net charge on the capacitor is 0, but by convention we used to tell the charge on the capacitor is here Q1, here Q2, here Q3. Okay, so Q1 will be how much here? C1V, similarly C2V, and here how much here? C3V. Okay, so C1V how much is there? C1 and into 100. So this will be here how much here? 100 microcoulomb. Next one how much is there? 200 microcoulomb. Here how much is there, students? See, 300 microcoulomb. And even if in case they ask the total charge, not total charge on this system, na? Sometimes they used to ask here. Now, so directly even you can tell, see, 6 into 100. Now directly see, Cp into V. That means how much coming here? 600 microcoulomb. Or you can see here also 100, 200, 300 like that. Is it? So after that, all these things we have seen. If in case, students, third one, potential difference anyhow same only, no problem. If in case they ask the energy ratio, is it? So if I ask here the energy ratio here, see, U equal to, you know very well, half CV square, is it? As the potential is constant, what we can tell, U is directly proportional to C. Okay, that means energy ratio in these capacitors like U1, U2, U3, is it? So what will be the ratio? You can tell very well, this one, see, this ratio here. Now, so if in case I want to write here the ratio, so see here, hence if I write here the U1 is to U2 is to U3 is given by here 1 microfarad, 2 microfarad, 3 microfarad. Okay, so this will be the energy ratio is there. And if in case they ask individual energies here like U1, you can use the formula half C1 V square. If they ask U2, no, you can use the formula half C2 V square. If they ask U3, you can use the formula half C3 V square. Okay, and all these values are given. And remember that here, if in case this is microfarad, so whatever answer will come, this answer will come here in a microjoule. Which unit? Microjoule. If in case you are not changing the unit of the capacitor, so if the capacitor in microfarad, the answer will come here in a microjoule. Okay, is it very clear? Now students, next one, let's take, we are going to see for this one here, mixed combination. So here you can see 6 and 3 connected in a series, and after that this 5 is connected in a parallel with this. So here if I write here, this is A, this is B. So first one anyhow equivalent here. So here if I write here, you can see very well, this 6 and 3 connected in series, that means again C1 C2 by C1 plus C2. So 6 into 3 by 6 plus 3, that means 18 by 9. How much coming here? 2 microfarad is there. No? How much? 2 microfarad. And here again one more capacitor is there. How much value is there? 5 microfarad. And here anyhow this battery is there. Okay, we have reduced this capacitor. Okay, then after that what will happen that here you can see very well, this 5 and 2 connected in a parallel. That means we can write here the overall equivalent. No? Equivalent. What this will come here equivalent? It will come here the 5 plus 2. No? Very easy. 5 plus 2. How much coming here? 7 microfarad is there. No? So if I draw here the equivalent diagram is there, see here like this here. No? See, 7 microfarad, and here this battery is there. 100 volt. No? This is clear. Now after that, if we will calculate here the, let's take for example, we are calculating the charge here. Okay, so see, on this, let's take charge is Q1. Okay, so remember that here on 5 microfarad capacitor, this charge Q1 is given by what directly? C1 into V. C1 how much here? 5. Battery how much here? 100. So 5 into 100, how much it will store here? It will store here 500 microcoulomb. No? Parallel combination, no problem. But remember that here, if in case we are calculating charge on this, so they are connected in series. That means if here charge is Q2, here also charge will be how much here? Q2. Okay. And to get this charge, what we'll do here? We have to calculate the charge on this equivalent is there. Now series means always equivalent here. So this Q2 will be what here? This Q2. This Q2 is given by here, see, 2 into 100. So 2 into 100. How much coming here? 200 microcoulomb. That means this capacitor, 200 microcoulomb left side plate, this side also 200 microcoulomb left side plate. Okay, so this thing we have got here the charges. After that, students, if in case you calculate the vertical potential and all that, na, so just like that we have done before also, na, in the same way we can do here, is it? So I hope so this thing is the very clear, na, capacitance, charge, all these things we can calculate very well. Okay, this thing no use, na. So next one, let's see here. Here the students, what is given here, very important, Wheatstone bridge. So see here, balanced Wheatstone bridge. What is this? See, it consists of 5 capacitors as shown in circuit diagram. See, in balanced bridge, capacitor C5 will not store any charge and energy, so it can be removed here. Okay, so what is the meaning of the balanced bridge? So what I am telling you here, see, for balanced bridge, no, for balanced Wheatstone bridge, what will happen that here, if in case this we used to read in electricity, but anyhow remember that here for balanced bridge, if in case here potential A, B, C, D. So what will happen that here for the balanced bridge here, students, this potential of B and D will be same. Remember that here as of now what will be there for balanced bridge, potential of point wait A, B, C, D, no, see here, VB equal to VD here, which let's take, I have make this here, see this is A, B, D, and let's take A, B, C, D. Let's take, I have given here the E, okay, because C I cannot use here. So what will happen? The potential of point B and potential of point D will become equal, okay. And in this situation, what will happen that here, if the potential is same, so if in case, if I talk about here the charge Q5 is given here, C5 and potential difference, VB minus VD, how much coming here? 0. That's why this capacitor will not store any charge and even energy also, okay. And after the, remember that here in balance condition, what will happen here? This C1 by C2 will be equal to C3 by C4, okay. C1 by C2 is equal to C3 by 4, like see, C1 by C2 is equal to C3 by C4. In another way, you can write like this also, see, C1 by C3 is equal to C2 by C4. All story same only. Even you can write C1 by C3 is equal to C2 by C4, okay. You can see very well, the story is same only, okay. So what we are going to see here, here we are going to see this case here. So remember that here this is also Wheatstone bridge, no? This is also Wheatstone bridge. So if in case I will simplify this here, so after simplification, what will happen that here, this will become like this here, like this, no? Like this only it will form here, okay. This will also form here, the Wheatstone bridge is there, okay, like this. Let's take this is A, this is B, okay. And even if you want to see also, see here, this is point A is there and this is point B is there, okay. So what will happen that here, let's take, I have taken this is point M, this is point N, so this will become here, see, this is point M, this will become point N. Now you can just see it very well, you will get it here. So here capacitance C, and this is also capacitance C, okay. So what will happen that here, kindly see here first, if you will observe here very properly, this C by C and here this C by C, one by one both the sides it is what, balanced, is it? So in this situation what we can do here, see, this capacitance like this we can write here, see, like this, no, like this here, like this, is it, like this. So this is A and this is anyhow B, C, C, and here also C, C. So what we can tell students here, this C and C connected in a, see, this C and C connected in a series. So how much? C by 2, C by 2, that means I can write here, see here, C by C2, and down also how much is there, C by 2, okay, and here A and here B. Then after that you can see this C by 2 connected in a parallel, that means here equivalent will come what here, this equivalent will come here, C by 2 plus C by 2, how much coming here, C. So what we are understanding, if Wheatstone bridge is there, if all are C, then what will happen, equivalent will be also C, okay. Remember that very well, okay. And even I will tell you one question for the homework, no? This question even you can try also, see, if this is given, even you can comment the answers, no? See, let's take like this given here, okay, like this, no? See, this is A, this is B, and how I have given here the values, let's take here, this is 2 microfarad, 4 microfarad, okay, 6 microfarad, 12 microfarad, and let's take in the middle, it is given here, let's take 2 microfarad, okay. So students, if we have to calculate the equivalent between point A and B, what can be the answer? Even this bridge is balanced or not? No, just identify it and just write the final answer. What is the equivalent between point A and B? Okay. Now students, next one, see. Method of same potential. What I am telling? Method of same potentials. So students, here you have to remember that here. Let's take for example, what I am telling, let's take one capacitor is there like this. Okay. This is A, this is B, okay, and here how much charge is stored? Q minus Q. So what we can write here? I can write here this VA minus VB is equal to what? Q by C, okay. But if in case what is there, what I am telling that here, if in case what is there here, let's take capacitance is not there and they are directly connected here. Now, so if they are directly connected means how much charge they will store? They will store the zero charge. That means in this situation we can write here VA minus VB is equal to 0. That means potential at point A and potential at point B will be same here. Now because they are directly shorted here. Okay. But remember that here this concept we can use it here. Now this concept we can use. But we can never use the concept. Let's take if in case this battery, this capacitor is directly connected to this battery here. And see here. We can't tell like A and B at the same potential by the same method here. Okay. Here what will happen that here this method will fail is there. Okay. So remember that here whenever the 2 points are directly shorted, what will happen? Potential at point A and B will be what? Same. But directly we cannot apply to the battery here. Okay. So what will happen that here? Let's check here. This side we can see here. So here we are going to find out what is the equivalent capacitance. This is maybe looking like a Wheatstone bridge, but it's not. Let's see here, please. See. So see here these points are directly shorted. So this is A. Here we can write here A, and here also what is there? A. Is it? Similarly, see. This is B, and here also how much here? B is. So see here. This A, see here A, and this is B. So here also what is there? B. Now students, you can identify it very well. What I am telling, see. This is connected between A and B. This is connected between A and B. This is also connected between A and B. Is it? So if in case I write here the equivalent. So what will happen that here? This C, and this C, all these CC students. Now they are connected in what? They are connected in a parallel. Which connection? Parallel connection. Okay. And here this equivalent is given here what? This will come here 3C. Okay. Can you remember that? Here also if you will see. In this situation, second situation. So here what will happen that, see here, you may think like this, okay, this is a very easy, but remember that here one thing, here B is there, so here also B, and here also B. So if you will see that here, let's take here potential VB, is it? So here what will happen? Potential difference. If I ask the charge, how much charge it will store? So C into VB minus VB, how much charge it will store? 0 charge. That means this capacitor can be removed. What I'm telling, this capacitor can be removed. This capacitor can be removed because across the capacitor potential difference how much? 0. That means only this is there connected in a parallel. Okay. So in this situation equivalent what will happen that here? C plus C, and here that will come here 2C. Even if you write for the equivalent diagram will be like this here. See, you can see here CC, and here A, here B here. Is it? So this is the method of the same potential. Okay. Even we will learn in a electricity also. Okay. Great. Now students, see here also. Here also let's see. Here also see. Here we want to find out the potential equivalent capacitance between point A and B. So see here please. See, all these points are directly shorted. So let's take here. This is O. This is point B. That means here also how much point? B. See, directly shorted. Here also how much point? B. Directly shorted. Okay. So students, if I write here the equivalent formula, equivalent diagram. So see, this is O is there. This capacitor connected between O and B, right here the 4C. Next one, if I write here now, see this 6C connected between O and B. Is it? After that, see this 8C connected between O and B. Is it? This, how much is there? 8C. This is the B. Okay. After that, what will happen that here? See, one more is there, 9C connected between what? A and O. Okay, so see like this is there. This is the equivalent diagram here. How much is given, students? 9C. Is it? So now after that you can calculate it very easily and you can get here the answer CAB very easily. Okay, anyhow this and parallel, that means 6 plus 4 plus 8, that means 6 plus 4 10, 10 plus 8 how much here? 18. Then 18 and 9 in a series. So 18 into 9 by 18 plus 9 means 27. 27, is it? And then you just simplify this, you will get here the answer here. See C, and here also C, you will get here the answer. So okay, let's solve it. 9 3 are 27, and how much coming here? 6C. Answer will come 6C. Is it? See, this was the first one. Second one, students, if I write here, see, here also. See here. Looking somewhat complex now, but not that. See here, please. See, this is X. So, see here, X. Here, X. Now, see here, this directly also written X. This is X. And here also we can write here X. Okay. After the students, it will go for the next one. See, this is Y now. So, here how much? Y. Here also how much? Y. Okay. So, what will happen that here, if you check individual capacitors, this is connected between X and Y, X and Y, X and Y, X and Y. That means all four is connected across X and Y. That means, students, you can see very well here, this equivalent how much here? C, 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 all connected in a parallel. How much coming here? 4C. Okay. Even if I draw here the equivalent diagram also, see, again and again I am drawing here the same thing. See, this how many capacitors are there? 4 capacitors are there. You can connect like this is there. Now, this is X, this is Y, and this is C, 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 C. Is it? So, students, this is the method of the same potential. Now, you can see it very well. Is it? Great. Now, students, let's come to this one is there. Little bit complex, no? Little bit complex. Sometimes what will happen? Series combination will not work. Parallel combination will also not work. So, that time, this symmetry method is needed here. So, see, what is the symmetry method? See here. If we draw a line perpendicular to symmetry line, then all the junctions on this line will be at same potential as shown in circuit diagram. So, students, here they are talking about the two kinds of line. They are talking about the first is symmetry line. So, see, first I will draw here the symmetry line is there. Now, see, this is the symmetry line. This is which line, students? This is the symmetry line. Now, this is the symmetry line here as well. Symmetry line. After that, you will see here, students, above this line and down this line, circuit is very, very similar, just like a mirror. Okay. After that, what will happen that here? Perpendicular to this, I will draw one more line is there. See, like this. Like this line is there. Now, like this. Okay. So, here, students, what will happen that here? In this situation, this is called which line? This is called the perpendicular line. Perpendicular line, na? Perpendicular line, na? Perpendicular to the symmetrical line, so perpendicular line. So, here also you can see left side and right side of the circuit is same. Okay. So, here what will happen that? Very easy, very easy. What are the junctions are there? See, this is, let's take point ABC we can't take because you already there. So, here let's take, I am taking here J, here K, and here L. Okay. So, what will happen that here in this situation all the junctions will be at same potential. That means what we can tell here, this Vj is equal to Vk is equal to Vl. Now, Vj, Vk, Vl. Okay. That means as the potential is same, potential difference will be 0. That means, students, this one will not store any charge. It can be removed. This one will also not store any charge. It can be removed. Okay. So, the moment you will remove it here, what kind of circuit diagram will form here? See here. After that, see, this C and this C will form in a series. It will become here C by 2. Okay. This C and this C will also form in a series. And what this will become here? This one will also become here, students, C by 2. Okay. This C and this C will also form in a series. Okay. That means again what will become here, students? This will also become here C by 2. Okay. So, this is A, this is B. Now, students, C by 2, C by 2, C by 2. All are connected in a parallel. So, hence equivalent CAB. See, now very easy. What we have got? 3 into C by 2. That means answer 3C by 2. Very easy. Symmetrical line. Draw the perpendicular line. All the junctions will be at same potential. Remove the respective capacitors. Very easy. Okay. Next one, students. Let's see here. Here. No, let's see here. Here also, students, looking like a hexagon, is it? So, first let me draw here the symmetrical line here. No? So, across A and B we have to calculate now. So, see here, students. See. I have drawn here one symmetrical line. Which line is there? This is the, students, symmetrical line. Okay. So, again you see above this line and down this line, what is there? The circuit is the very similar here. Okay. After that, what I will do here? I will draw here the one like this. One line I will draw here perpendicular to this like this here. No, like this. This line is there. Okay. So, students, this is called which line? This is called here the perpendicular line. Which line? Perpendicular line. So, students, remember that one thing in this situation, this is called the connection removal method. What is this? If the 2 points at the same potential, they can be connected. So, 2 points at the same potential, those are already connected, they can be removed also. Okay, that is called what? Connection removal method. So, here what will happen at here? This thing, they both are at the which potential? Same potential. They can be removed also. In which direction? They will be removed along the line here. Again, How you will remove? You will remove along the line. You can't remove like this. How you have to remove? You have to remove like this. This is called what? Connection removal method. Okay. So students, if I will draw here, see here, I'm drawing for you. See, this is C, this is C. Okay, and again this is C, and here also C. Okay, and this is C and C. This one we have removed now. So see, I'll write here with the white line. See, this one we have removed here. This C and this C is removed here. Now even you can take here. Let's take this as M comma N. So see, M has came here. Okay. Similarly, students, in the mirror formation, even we can this side also we can draw like this here. See, is it like this? Is it? You can see very well. Is it? And see here I have removed here. Now this thing we have removed it here. Okay. Here, what is this? This is the N. And what are the capacitors are there anyhow? This all are what? CC. Is it? C. Very easy. We have just removed this connection. Okay, students. So what will happen at here? If you will simplify this somewhat. No? If I simplify this somewhat more. So see, this C and C is connected in a series C by 2. After that you see this C and this C in a series. So C and series how much here? C by 2. Then C by 2 and this C in a parallel. So C by 2 plus C how much here? 3C by 2. Okay. So this 3C by 2. And see, this C and this C also in a series here. No? But okay, I'll write here like this, C. Like this, C. This is C. This is students 3C by 2. This is again C. Okay, similarly down also you can write here C, and this side also C, and here how much students is there? 3C by 2. Okay, you can see very well here. See, this CC, C by 2, this one and this one I kept here. Is it? And how much coming? Again I have told you this 3C by 2 and this 3C by 2. Again I am telling C. This C and C in a series, C by 2, then C by 2 and C in a parallel. So C plus C by 2 means 3C by 2. Okay. Now what will happen at here? You see here this C, 3C by 2 in a series. So if in case they are in a series means we can use the formula C. 1 by C is equal to what we can do? 1 by C plus 1 by C plus 2 by 3C. Okay. Take the LCM here please. 3C. Now here 1 by CS only. Okay. For you I am just solving. Okay. So what will come here? It will come here 3 plus 3 plus 2. Okay. So students, it will come here CS equal to 336 plus 2 8. That means 3C by 8. Okay. So students, what we can tell here? If I draw here the one diagram here. So this is here. This is C by 2. This is how much coming here, students? See, this is coming here 3C by 8. Down also how much it will come here? It will come here 3C by 8. Okay, 3C by 8. 3C by 8, C by 2, 3C by 8. All of them now connected what? They are both connected, all three are connected in a parallel. So if I write here the equivalent, very easy. 3C by 8 plus 3C by 8, it will become here 6C by 8. No? 6C by 8 plus C by 2. No? See, 3C by 8 plus 3C by 8, 6C by 8 plus C by 2. Okay, just take the LCM here. 8, so what this will become here? 6C plus 4C. That means what answer will come here? 6 plus 4, 10C by 8, and again you divide here, it will become here 5C by 4. Okay, so students, you can see very well here the equivalent between point A and B will come what here? 5C by 4. Same concept will be applicable for the resistors also. Okay, now students, see the next one, infinite ladder method. So students, in case of infinite ladder method, what will happen at here? See, these capacitors are there now, like this, they are going towards the infinity. So students, if I just take here this, so what will happen that here A and B is there now. So from A and B you can see this C is there, 2C, C is the 2C. Okay. Now students, if I put here one point here, see, let me change here the color somewhat. No, see this one here, this color I have taken. If I write here the A dash and here B dash, so you see the circuit from AB and then you see the circuit from A dash and B dash. What will happen? The circuit will be similar. Is it? Here when you will remove this here, what will happen that here? If you hide this, so here also, if from the ocean you remove just one branch, what will happen? The equivalent is not going to change. Okay. So whatever is the equivalent between AB, same is the equivalent between A dash and B dash also. Okay. So what I can write here, let's take students, the equivalent between point A and B, how much here? X. So across A dash, B dash will be also how much here? X. Okay. So students, if I write here the equivalent here, see, this is 2C. And here students, see, this is X, anyhow here, see, this is A dash, B dash is there. Okay. And here this AB. And here we have connected here the C. No? And anyhow what is there? Students, here equivalent is how much here? X. Okay. So now you can see very well here what we can tell. See, this one, this 2C and this X connected in series. So when they are connected in series, C1, C2 by C1 plus C2. Okay. So if I write here, one more diagram is there here. So diagram will be like this here. See, this is C here, and students here it will become here 2cx by C, 2cx by 2c plus x. Okay, and here A and B is there. Okay, C1, C2 by C1 plus C2. Now students, what we can write here as equivalent x equal to C. This and this connected in a parallel. So we can write here C plus 2cx by 2c plus x. Okay. Now just simplify this. Let's take here LCM is how much here? 2c plus x. Now, so see here c into 2c plus x plus 2cx. Now, kindly see here very well, because calculations are very, very important. Is it? Now students, just simplify this here. So see x and here 2c plus x is equal to how much is there? You can write here 2c square plus cx plus 2cx. Again, kindly multiply here. 2cx plus x square is equal to 2c square. And here what will become here? If I see here cx plus 2cx, that means it will become here cx plus anyhow 2cx. Why I have done like this? So that this 2cx and this 2cx we can remove. So students, anyhow we can write here x square minus cx and minus 2c square equal to 0. Okay. So now students, if I will compare this equation, if I compare this equation with which one? Ax square plus bx plus c equal to 0. Okay. So a will come 1, b will come minus c, and okay, I can't write ax plus bx square plus c because anyhow c is there. So m and o, okay, j k l m, okay. Okay, a b c here. Now let's take here, this is the small c. Let's take small c. Okay. So what will happen that here students, if I write here c, we can write here a equal to 1, b equal to how much is there? Minus c, and small c. The small c equal to how much is there students? C minus 2c square. Okay. Again I'm telling that here, even if you want, if you can write here e also. What you can write here? You can write here e also. Okay. So a equal to 1, b equal to minus c, and e equal to minus 2c square. Now students, after that what will happen that here, if in case you want to write here the Siddharacharya method. So what is the Siddharacharya method? See, x equal to minus b plus minus square root of b square minus 4ac, but I will write here the e by 2a is there. Okay. Now students, see, minus b value, how much given here? See, b value is the minus c, e value is the minus 2c square. Let me write here just b value is minus c and e value is minus 2c square, a value is 1. Now this is the thing. This is the thing is there. Is it? So students, now we can just put here. So b value how much is there? Minus c plus minus b square. B square how much is there? See, c square minus 4. A value how much is there students? 1. And e how much coming here? See, e is coming here students minus 2c square by 2a. By 2a means 2 into 1. Now we are just simplifying this. So what this will come here? See, c plus minus square root of c square plus 8c square. That means how much coming here? The 9c square by 2. So students, we can write here c plus minus. This will become here the 3c by 2. This is the value of x. So from here students, how many roots are there? If I write here the first root, this x will come here what? C plus 3c by 2. So see here c plus 3c by 2, that means 4c by 2. That means x will come here the 2c. Second one, if I write here the second root, x2 equal to c minus 3c by 2. That means students, this x2 will come here minus c. And you know very well, the capacitance cannot be negative. So what is the correct answer? The correct answer is here 2c. That means the equivalent between point A and B, how much here? It is the 2c. Okay. Now students, last one here, see. If in case students, this kind of cubical arrangement is there, cubical arrangement of the capacitors. Here one cube is there, and in each and every sides one capacitor is connected. Okay. So students, remember that here one by one. If I take here the sides, which one? Body diagonal, that means from 1 to 4. So students, remember that here C1 to 4. So in this situation, remember that here 1 to 4 all are the capacitors. Okay. So in this situation students, the capacitance will be how much here? 6c by 5. Remember that here how much here? 6c by 5 here. Second one, this is the which one? Again I'm telling you, this is the body diagonal. Body diagonal. Body diagonal. Okay. Next one students, here if I take here 1 to 3. So in this situation students, it will be 4c by 3. Okay. And this is which diagonal students here? This is the face diagonal. Now face diagonal. Face diagonal. Third one. If in case I like this sidewise. Now I side this. So students, here in this situation, what will happen that here, remember that here this will become here the 12c by 7. Which one? Sidewise. 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 W-I-S-E. Na? Sidewise. Okay. So let me just check here. Anyhow, correct only. Na? So what is there, students, here? One is the, anyhow, 6c by 5. Next one, what is there? 4c by 3. And next one, what is there? 12c by 7. Correct only. Is it, students? So just see it very well. So I hope so, students, all these 8 cases are very clear to you. Study it very well. Thank you so much. Take care.